just for the recording. Today we are going to talk about more semantics in C++. We already know about left values and right values, and these are some examples of L values and R values. So the blue stuff is the L value, right stuff is the R value. Anything that can behave like... Efendim?
Hocam şimdi girebiliyorlar mı acaba?
Girebildiniz mi arkadaşlar? Tamam.
Ha, tamam hocam. Tamam.
Oldu, görüşürüz. So anything, these are greens are R values and these are the L values. We already talked about it. This one, okay, this one is a little bit different than the, this is a regular function, right? It just returns a integer. This one is okay. I am assigning whatever this one is returning to I. I am trying to take the address of an R value and assign it to P. Doesn't work. This is bad, right? This is okay. This one is bad. Why? You cannot take the address of an R value, or you cannot modify the value of an R value, okay? So R value cannot be used on the left side of a assignment operation. We already know those, okay? So why do I keep talking about this kind of stuff? Because I am going to do this. I am going to do this. Let's say I have a class like this, class array, whatever it is, doesn't matter, okay? It's like PF array, right? This is PF. This is not std array, by the way. This is like PF array class. Inside PF array, we have what? A pointer, right? A pointer to some memory location. So depending on my array size, it could be maybe megabytes of data in there, right? Okay. Let's say I have defined this plus operator. Plus operator takes two arrays and it adds them together. It's like vector addition, right? It's like three-dimensional array. I add them. 9.1 plus 3.1 is this, and this. Like just vector addition, right? Add two vectors, okay? It's not concatenation, it's just vector addition. So if I like to do this, it is nice by defining this, because I am taking two arrays and I am returning an array. By defining this, I can do this kind of stuff, right? It's nice. But let's see what's happening in terms of how much memory I am using, okay? So every time, first of all, this will be done first, right, okay? Because if I look at this expression, okay, it's an assignment, initialization, but let's say it's an assignment. Assignment, the precedence of the assignment is the last. Plus will be done first, but this plus will be done first because of the associativity rules, right? So I will add these two. Then whatever it returns, I will add that one with this one. Whatever it returns, I will assign it to this A. So how many temporary objects will be created? How many temporary array objects will be created in this expression? I already have A, B, C, D. They are not temporary. Yeah.
Two.
Let's see. One of them is this one. Yeah. The second one is this one. Yeah, I guess it will be two. So there will be two temporary objects created. If my array is of size 2 megabytes, I will spend time to create those temporary objects, right? And I will spend some time to delete them too. That's the inefficiency. Why do I keep talking about temporary objects? Because it is algorithm, inside the algorithm, right? It says that when you start executing this array, okay, make a new array, this res, assign left to it, then do this plus assignment, addition, then return result, okay? Then after my function is done, that temporary object will be dead. Since I have two plus operators, there will be two temporary objects will be created and they will be destroyed. If my array is very large, then I am in trouble in terms of performance issues, in terms of memory usage, in terms of CPU usage. Okay, I have to allocate and deallocate and etc. Because to make a new array with this initialization, I have to call the copy constructor. Remember, copy constructor says that allocate me some memory whose size is same as this one, etc. Okay, so that's the problem. This is the picture. Again, I am using this nice person's slides. Continuing from that. Okay, this is A, this is B, C, D. Each one is pointing to some large memory location inside my memory. When I first call this plus operator, it will make a new res. Okay, so this will be my first res. Okay, first I will get this B and I will copy this B to this location. Then I will plus assignment to this one, and then when this one is done, okay, this res is returned. This time this res plus this D will be added. Okay, another res will be constructed. This is the first result object, and this is the second one. Again, the operation will be done, and then I am going to assign this result to this one. Okay, so this is called value semantics. Okay, this is called value semantics. All the things that I'm returning are values. Okay, all the things that I am returning are values, and I cannot do anything about them. Our values are our values. I cannot modify them. It looks like I will have to live this life. Maybe you could say that why are we implementing array like this? Okay, instead of returning an array, object array, maybe we should return an array reference, right? If I return an array reference, then maybe I can keep modifying that array reference, the same object over and over again. No, it is not that easy to write those kind of functions. Okay, if you say that I am going to use the same result objects, okay, all the time, well, it is not easy to write those kind of plus operators. It will make your plus operator a little bit complicated, and you can say that I am going to allocate my well, I mean, as I said, this is nice enough, this is good enough, but kind of inefficient because you are returning something that needs to be destroyed and reconstructed again if you keep doing this. So the better thing, the C people would do this. They say that, okay, if you're going to add an efficient function, it should be add object 1, object 2, and result. You allocate your memory and you send your result to that function, so that this add function doesn't have to create its own temporary object, right? You are already sending it. And the nice thing is that if you return whatever your result is from this function, then I can add that one as a pointer, right? I can add that one to object 2 and another result. Okay, I can do this kind of optimizations in C type of syntax. But as I said before, in object-oriented world, we don't like this kind of stuff. We don't want to talk about what is going on with the memory. I like to use it this way. Okay, I like to use it this way. This is nice enough. I want to use this one, and I like to be efficient. So this is what we are going to do. We are going to switch from value semantics to move semantics. In the move semantics, we will do this. Okay. I mean, if you are going to add these two, you are going to make a temporary anyways. So I did this temporary and this is my result. But I know that the result is going to die, right? and it uses some space. So why do I have to make a new array object with these two? Okay, just keep using this one. Keep using this one. That's what I do. So I copy this one to this result and add it up and return this one. And A, and my object A, remember, A will point to this one. So nice thing is this, I will not, oh, this slide is so crowded. I don't want to erase whatever I have written before. Okay, so remember, this is temporary, and I will make a new object A, and I will create some space. Now I am saying that, okay, temporary is this one, A plus C. I am not going to delete this part. I will make a new result, yeah, but that result will keep using this part, okay. So I will use that part, and then I am not going to delete this part. My new object A will point to that part. I am going to, should I, yeah, okay. Okay, should I do this? Yeah, I am doing this. So instead of using 1, 2 temporary objects, and one pointer pointing to its own object somewhere, okay, I am just using one temporary object, and in fact, it turns out that it is not a temporary object at all. It is part of this object A, right? So I did not waste any memory space at all, okay? I did not deallocate anything. I kept using the same space all over the operation, okay? This is how it is done in C++. So how am I going to do this? I will add two things. One is a move constructor. Move constructor says that, okay, I have a constructor, like a copy constructor. I am going to construct myself by making a copy of some other object, but it is not going to be a copy. I am going to steal its resources. I know that it has a double pointer, it is pointing to some space, and I know that this object, whatever is passed to me, is going to die. If it is going to die, then why don't I steal, okay, its resources and let the object die afterwards, okay? So if that object is going to die, it dies, but it doesn't take the memory with it because I am using the memory, okay? That's what the move constructor is. That's how it is written, okay? This is the move constructor. Copy constructor, move constructor. Copy assignment, that's what I've been doing all along, right? This is the move assignment. So if I am doing an assignment, if I know that the other side, whatever is returned, whatever is given to me is going to die, then I will use this one. So this one will be like, let's say, okay, I'm making a, let's use it somewhere. An array, or, okay, let's talk about strings, our S3 strings. String, okay, S1, as a parameter to the S1, okay, copy constructor, S2 plus S3, okay. This one uses the move constructor, not the copy constructor, okay, in C++11. This one uses the move constructor, not the copy constructor. Also, this one, S1 gets the value of S2, S3. This one uses the move assignment, not the copy assignment. Why? Because whatever this one returns is going to die, right? It's a temporary object, it's going to die. Since it is going to die, since I know it, right? Since I know it, then a compiler can call this function and this function. So in total, remember our big three rule. Big three rule was copy constructor, okay, assignment operator, and destructor. These are special. If you don't define them, the default versions of them will be defined. That's why you should be very careful, because copying objects are done very frequently in C++, call by value, etc. Right? So also assignment is done very frequently. We should be careful about those. But if you like to be careful about your memory operations, your CPU operations about these kind of statements, then C++ added this, the fourth one and the fifth one. That's why we call them big five. Okay, two more additions. Okay, what happens if you don't use them? If you don't use them, okay, if you don't use them, you are not going to be aware of them, and your old code will work. Okay, there are default. Okay, what is the default implementation? What is the default copy constructor? What does the default copy constructor do? It just does the member-wise copy, right? What does the default assignment do? It does the member-wise copy. And this one is, it does the member-wise move copy. And this one does the member-wise move assignment. Okay? So if you don't define your move assignment or move constructor, one will define for you, and that's default behavior is calling the move assignment or move constructor functions of the corresponding elements. Okay? So, good. What else can we say? Oh, okay, so see this one? This one? This is a plus operator. This plus operator will work on, okay, L values, okay, constant L values. But this one says that on the left, I will have a movable stuff. And I'm going to show you how it works. Okay, two assignment operators. I read them both. And where is my code for that assignment operator? Yeah, here it is. So this is our regular assignment operator. Compiler knows that both A and B will stay, they will not be dead. Okay, so it uses this one. But if the compiler knows that one of the objects will be dead, it calls this one. See what it does? I know that my left object is going to be dead if compiler calls this one. Okay, then I can use left as it is and add right to it, and I just return left. Okay, and the compiler is smart enough to call if I am doing this. Okay, if I am doing this. So tell me if this is copy plus, this is move plus. Which one is this? Copy plus or move plus? And which one is this? Exactly, this one is copy plus. This one is going to be this. Why? Because B or C, they will not be dead, right? They will continue living, because then I cannot modify them. So I take them as it is. But this one is a move plus, this one. Why? Because whatever B plus C returns, it will be dead soon. Okay? If it's going to be dead soon, then why should I make a copy of it, etc.? Okay? Use its space. I just left plus assignment right. How about this assignment? What kind of assignment is this? Copy assignment or move assignment? Move assignment, right? Why? Because whatever this plus operator returns is a temporary, which is this one, right? And it will be dead. So why don't I use its internal resources? Okay? So I did not, this is as efficient as a C implementation, because I did not waste any space, even this one, even our first temporary object, because I use it as the data member of this result, okay, this result, And I was going to do that anyway. So at the end, I am going to have both my A and B and C and the result. So they all will exist, and I will have this picture. Okay. So that's what move semantics does. Okay. So we are going to write our copy constructor, our copy assignment, and sometimes these kind of plus operators. Okay. Saying that, okay, I know how to do this in the right way. In terms of memory usage and CPU usage, I will bet that I will bet at an advantage position. Nice thing is, they have overloaded all of the STL classes with the move semantic stuff. All of the STL classes, okay, all of the STL classes define their move constructors, move assignment operators, plus when you do this, see, when I say vector of let's say many objects, okay, mv, when you say mv dot push back a money object, okay, mv dot push money object, you know that a temporary money object will be created, and it will pass to pushback, and that pushback is going to make a copy of it and keep its copy in it, right? That's what you would expect. That's what has been happening with C++ 98 before C++ 11. But after C++ 11, since they have implemented this pushback with the overload of move semantics, then I am not going to kill this money object altogether. I am going to use its internal resources. If it is a, well, money object is not a, maybe money is not a very good example because it doesn't keep anything large in it. Maybe PFRA would have been a better example, but it works that way. Let's go to the documentation of yeah, not this one, no, C++ reference, and let's try to go to our vector class. Stop doing this. What are you doing?
I was writing an email.
You are writing an email?
Yes.
That's what I'm saying. Don't do it. Okay. Where is my pushback? Yeah. Let's go to pushback. See, pushback has this one, constant reference something. Okay, and pushback has this one. Okay. So it is implemented. Since C++ 11 we have this, but they have changed it after C++ 20. Well, it's the same thing, but only they say that it is the constant repression thing. I didn't talk about it because this one, the meaning of this one kind of changed after C++ 17 or something like that. So I'm not going to talk about it. Okay, so all of the STL containers, they have implemented value semantic interfaces. Okay, so don't worry about I am sending this and it will be copied and copied and copied again. These will be inefficient. No, it is not inefficient anymore. It will be optimized. The nice thing is this: you have a code written in C++ 98, and it is using lots of STL libraries. Without making any modification, compile your code with C++ 11 compiler, and if it is using lots of STL classes, your code will get faster somehow, right? It's exactly the same code, okay, without changing anything, just changing the compiler, it will get faster. Why? Because without you knowing it, your code will start using this kind of pushbacks, right? The compiler now says that I know that this person's pushback is using a temporary object, so I am going to call this one, not this one. Okay, call this one, not that one. Previously in C++ 98, we didn't have this choice. It always had to be this one. Okay, good. Okay. So let's see some more examples that will be kind of clear. Should I? Yeah, but let's look at this one. So we already know how to write this one and this one, right? This is a reference taking function, L value reference parameter. This is a constant L value reference parameter, and this is a R value reference parameter. Three type of references. Constant reference, okay, but those are constant L value references, okay. These two. This one is an R value reference. It's interesting, right? What is the R value? X plus Y returns an R value, right? I may not assign anything to it. It's an R value. I cannot, but I can take a reference to an R value and I can write these kind of functions. If whatever I have is an R value, that means it's going to be killed. It's going to be temporary. Maybe I can steal its internal resources like its pointers and etc. Or reuse it. Okay? Or reuse it. Good, okay. So I have an X object, and here I have another. I have another. What is? Okay, I got confused about this. So this is an object declaration. This is a function declaration, right? Both of them. This one, the type of this X is this capital X. This one returns an capital X. Okay, this one takes an, okay, this one will call this one, right? And this one will call this one. Okay, maybe make it red. We'll call this one. How about this one? Which one would it call? That one? Yeah, I think for that one to be called, I need a constant X, okay? So let's write another one. A constant X CX, okay? Then I will, when I say F constant X, of course this one will call this one. Good. So, more ways to overload our functions. As I said before, if you don't have anything to do with the performance, that kind of stuff, you may ignore the smooth semantics, but people are kind of not comfortable about it, that C++ knowingly wasting memory and CPU time. So they have invented this. Okay. Any questions up to now? So let's see how it really works. Let's write some classes. These are some of the rules. Move semantics. Okay. Instead of copying something from other objects, we steal their resources. But whatever object I am stealing from, I don't leave it in an unstable situation. I leave it in a stable, destructible state. Okay? I say that, okay, I have stolen your internal memory, okay, whatever you are using, I have stolen it. I am letting you know, okay? So when you die properly. So if I am taking their dynamically allocated memory space, maybe I should assign a null pointer to their where is it? This pointer, because if I don't assign a null pointer to it, when this object dies, it will try to delete whatever it is pointing to, but I have stolen it, right? So that would be a bad thing. So I will assign a null pointer to this value so that it doesn't delete it. That's what it says. That's what it says. Move semantics. Okay, instead of copying, steal the resources, leave the other object in a destructible state. Okay, our rule of 3 becomes rule of 5. All standard library components were extended after C++ 11. Okay, and we are all backwards compatible. Whatever we write in C++ 98 will work as it is without any modification. Okay, and sometimes they will get faster if they are using our libraries. Okay, if they are using libraries. So there is a homework. You are trying to make homework. Those are homework faces. You are trying to. There is a deadline for a homework today. Is that correct? No? I'm talking to you. Weren't you doing your homework? What homework? What? Circuit? That's what happens always, yeah. People prefer my class to their circuit homeworks. Are you doing my homework? Well, you need a computer to do my homeworks. Okay. Okay. Okay, don't do homeworks in my class. So everything will be compatible, but if you like to do more, then you do this move semantics. We implement all style member functions with L value references, but do not implement the L value reference overloading versions. We keep our old behavior. Okay. If we implement only R value operations, okay, we cannot call these on L values. No default copy constructor or operator assignment will be generated, okay? If you implement R value operations are move semantics. So, I mean, if you implement one of these move constructor or move assignment, then you have to implement all of that stuff, okay? Because no assignment operator or copy constructor will be produced for you, okay? So again, these are compatible rules. If you don't know anything about move semantics, then you will be fine in terms of what code compiles and runs. But your code will be a little bit slower. So serious performance gain, okay? Serious performance gain for many cases, except for some rare are return value optimization situations. Well, I mean, this is if a function returns a temporary object. Remember how I told you about the. Remember how I told you about the. Remember how I told you about the. Where did she go? The person next to you, is she? Yeah. Wake her up. I know what you guys are doing. For some reason, I know. I don't want to know. I like to keep my eye closed, but I cannot do this. This is really difficult to ignore you. And, okay? When I talk to you, if I feel that you are not listening to me, I cannot talk for some reason. Okay? At least try to keep your eyes like this. I don't know what. You know those kind of glasses with open eyes? Could you guys buy one of those? Glasses with open eye. Yeah, this one. Buy this one. Okay, and do whatever you do behind the glasses. Human psychology. People cannot talk to people if they sleep in front of me. Okay. This one is good. Are they the same person? No, they are. Oh, they are taking their pictures and they are putting their eyes in it. Good idea. Well, I cannot use this because I cannot talk while my eyes are closed. Okay, how much is this? shopping. I should buy 5-10 of them, and it's expensive. Ah, this one is good. This one is I did my homework for the last 10 hours, but it's expensive. Anyways, okay. So some return value optimization stuff. C++ 98 compiler is already smart, okay? If it knows that the return temporary value will be that, it doesn't make another copy of it. Usually, for this one, there are two optimizations, okay? You need to call the copy constructor, but I think I talked about this. Sometimes the copy constructors are not called. There are some shortcut solutions, okay? So the compiler does that, but those are some rare situations. I mean, I have been doing this already, if I can do it, but most of the time that cannot be done. And in fact, sometimes I don't want this to be happen. In that case, I think you would turn it off. Let me try to look at the GCC, and look for this return value optimization flag, RVO. Couldn't find it. Here, go to the online documentation, GCC RVO flags. Unfortunately, Stack Overflow again. I'm using something. Yeah. If my compiler is using return value optimization by the I see that there is an option something, and nobody answered it. What? It is listed under default C++ dialect options. So it's not the C++, okay, C++ dialect options. Go there. RVO. No. Okay. C++ standard allows an implementation to omit creating a temporary that is only used to initialize another object of the same type. Specifying this option disables that optimization and forces G++ to call the copy constructor in all cases. Understand? Okay. So without calling the copy constructor, there is an optimization. But if I always want this to happen without doing the return value optimization, then you can turn off that optimization or the dialect flag to get that behavior. So my point is, okay, this RVO was happening already with our compilers, but it was some rare cases. If I like to use the same idea using the temporary objects memory, okay, not to waste memory, but not to construct and deconstruct objects over and over again, then switch to move semantics. Okay, let's look at this simple class. Okay, let's look at this simple class. By the way, my favorite class is still my favorite class, class A. Okay, what did I say? It defines a constructor, copy constructor, assignment operator, destructor. Now we know that it has a move constructor, it has a move assignment too. Okay, so it got richer. So let's look at this one. Whenever you are writing this move assignment copy, okay, this is the copy constructor. Okay, this copy constructor is written this way: the free all resources, then allocate and copy resources from right hand side. That's what we did with the PFRA. We freed our old resources. We said that I am going to get new array now. I have to delete my whatever I had before. I am deleting whatever I had before, and I am reallocating and I am copying them from the other one. That's what we did. Now this is what we are doing, okay? Free my old resources. I'm not going to use them, okay? And then move resources from the right-hand side, not copy, move them, okay? But modify the other side, so that, modify the other side, right-hand side, so that it is in a valid and destructible state. What do I mean by, okay? If they have a pointer that I am stealing, assign a null pointer to that pointer so that when it dies, it doesn't delete my object. Okay? An object is going to die doesn't mean that it's a junk object, okay? It is still alive. It is breathing. We should treat it with respect, okay? We should keep it in a destructible, valid state. Otherwise, when it dies, it's going to crash our whole system. We don't want that. Okay? Good. So what is the time? 21. Let's start talking about this generation of special member functions. When does the compiler produce those move operations and etc.? I think I will stop at this point for 10 minutes. When we come back, we'll talk about it. Okay? Good. 10 minutes.
Ben o zaman bilgisayarı açtırdığımızda bu şeyleri de yazdığımız, bu semantikleri de yazmamız, override etmemiz gerekiyor o zaman, değil mi? Yani mesela şey yapıyorduk ya, şeyle.
Assignment ve assignment constructor they are inherited but they are not yours dedik ya, aynısı.
Aynısı değil mi? Onlar
Evet.
aynısı.
Tabii ki yapman lazım.
Evet.
Gerekiyorsa tabii ki.
Bir de bende var dedim, ona rağmen aldım GTA. Çok param var, onlarla harcayacağımı veremiyorum. Neyse. Öyle cebim de cebime sığmıyor. Emre var mı? Emre. Ne yapıyorsun birader? Ne yapıyor bu ya? Nasılsın? Bir sorun. Duyamam, gel gel. Duyamam. Reklamını yazmadım. Denk gelmiş az önce galiba. Sürekli gelmiyor. Ceyran'a bırak ya. Ya ben 2-3 pantolon yiyeceğim. Sokalım. Şeyden. Tamam. Move'un yok. Şu an aynı. Move'un yok çünkü tanımlamış. Tanımlarsa Move'u tercih edecek.
Tamam, bu tercih.
Pardon.
Yok, kendisi çok iyi. Zaten aldım. Hani yazdım.
Ben de çok iyi yapmışım. Yazdım.
Yazdım. Çok iyi.
Sen mi yaptın? Tamam, kopyayı tercih edecek.
Niye?
Kopya alacak herhalde. Move ne demek abi? Move edition ne yapıyor? Move edition ne yapıyor? Bir dakika. Move edition ne yapıyor? Move edition ne yapıyor? Ne yapıyor? İşleri çarpmamak. Sen
Böyle
reis havalasın. O maçlar. Ben bir de kocuk getireceğim motorla beraber. Kocuğu ayağıma sararım.
Normal bir şey. Ne yapıyordum?
Neyse zor işte.
Çok anlamaz zaten. İki hafta sonra abi.
Yapsardım işte diyor. Onun şey olduğunu belli ediyor. Bu object silinecek yani.
Nasıl silinecek mi diye? Right value alıyor. Dur tamam. Tamam bak. Temporary right value ya. Temporary ise alamıyorsun. Temporary değilse alamazsın. Şöyle olsun. Beyazlıca ya. Bakıyor. Temporary mi değil. Right value değil. O zaman move'u çağır ama normal çağırsın. Çünkü move right value alıyorsun. İki yaparsın right value'dan. Right value olmadığı için copy etsen çağırıyor. Beyaz şekilde. Sonra bu temporary yapıyor. Bu right value veriyor.
Right böyle
Right value ile left value olan bir fonksiyon var. Onun adını operatör artı left right yok hayır bu da temporary.
Bunu kim kapatıyor yani? Koşuyor musunuz? Dışarı çıkın o zaman. Yok ya arkadaşlar hastalık var etrafta. Millet kırılıyor. İçeri şey tutamayız yani havasız.
Bir şey sorabilir miyim? Dördüncü ödevler.
Sor. Dönüyor. Hatırlamıyorum ama sor tabii.
Evet, text file ile alakalı bir şey istenmiş şu.
Aha, yazacaksın ve okuyacaksın.
Tam olarak o cümleyi biraz açıklar mısınız? Ne isteniyor text file ile alakalı? Kümeleri mi file'a yazacağız?
Objenin durumunu text file yazmakla ilgili bir fonksiyon yok mu orada?
Yazmakla alakalı bir fonksiyon ben görüyorum.
Karışmış öyleyse 4 ile 5. 5'te vardı öyleyse ha. 4 ile 5'i mi karıştırmış?
extraction var.
Ha?
Tier basınca oldu.
Ha, tamam öyleyse.
Ama file demek.
Ha?
File'a basın demek.
Yani eğer instruction extraction varsa zaten text file'a basıyor onu.
Text file ile alakalı bir şey yapacak mıyız dördüncü ödevde?
Hatırlayamadım ki şimdi onu ya. Sen onu bir İlhan'a sorsana. İlhan'a e-mail ile sor, ben de CC'de tut.
Nasıl yapacağım bilmiyorum.
Ha?
Öyle bir şey nasıl yapacağım bilmiyorum.
E-mail atıyorsun
Ya
İlhan'a.
onu biliyorum da.
Alt tarafta da CC kısmı var ya. Ne? Bilgi.
Tamam.
Copy. Carbon copy. CC ne demek biliyor musun?
Hayır.
CC şu. Bunu bilmiyor musunuz siz ya? Ha. Allah Allah. Ben kimlerle haşır neşir oluyorum bilmiyorum ya. Carbon copy işte bu.
Bunu biliyorum ya.
Biliyor musun bunu?
Biliyorum.
Bu karbon kopya, aralarına koyuyorsun onları,
Evet.
altta çıkıyor ya.
Kullanılıyor.
Şurada e-mail yazdığın zaman da burada, tamam mı? Kime dedim, İlhan dedim ya şuraya. Şuradaki bilgi kısmı şu CC bu. Bilgi diyor mu esasında carbon copy bu. Niye burada?
CC nerede hocam?
Bunun İngilizcesi CC. Şu da BCC. Tamam mı? Bunu nasıl bulurum? Gmail ile falan bulurum.
Ben bunu araştıracağım.
Araştırmaya gerek yok. İlhan'a e-mail at, beni de bilgide tut. Tamam. Bunlardan kullanmadınız mı siz hiç arkadaşlar? Carbon paper, Ha? Nerede kullandınız? Bir şey nerede kullanıyorduk biz bunları ya? Şu faturaların arasına konulur bu kesin. Eskiden yaparlardı, arasına koyarlardı. 2 kopyası olsun diye. Tüm devlet işleri bunda, bu karbon kağıdı olmasa devlet işi gitmezdi ya. Daktiloda falan koyarlar, biliyorsunuz değil mi onu? Daktilolar vardı ya, eski daktilolar, çat çat çat çat, mekanik. 2 kağıdın arasına bundan, hatta 3 kağıdın arasına bundan koyuyorlardı. Aynı anda 3 tane kopya çıkarıyordu. Ama bir hata yaparsan mahvoldun. Düzeltemiyorsun şu kağıttakileri. Çarpı çarpı atman lazım. Okay, so let's move on. Let's move on. So the two copy operations, copy constructor and copy assignment, are independent. We already know that. Okay. So the rule number one. Tell him to stop. Okay. Rule number one is the same rule. It did not change. Okay. The copy operations, copy constructor and copy assignment are independent. Declaring one of them doesn't affect the other one. Okay. You may have a copy constructor in your class, but no copy assignment, or just the opposite. Okay, and vice versa. No problems. So the rule number one did not change. But the move operations are not independent. Declare either prevents the compiler to generate the other. So if you declare the copy assignment or move assignment, copy constructor, move constructor will not be declared, or the vice versa. Okay, so the behavior is kind of different. So big five is the rules are a little bit involved because of the backwards compatibility issues. Okay, if any of the copy operation is declared, if any of the did that help? If any of the copy operation is declared, then none of the move operations will be generated. Okay. When you declare a copy constructor or copy assignment, move operations will not be generated. So there will be no default move assignment or move assignment or move constructor. That's the third rule. And the fourth rule is, okay, it is the same rule actually, and vice versa. Okay, 3 and 4. If any of the move operation is declared, then none of the copy operation will be generated. So these are the same rule actually. If a destructor is declared, then none of the move operations will be generated. And default constructor generated only, no constructor is declared, as the same as C++ 98. So this rule number 1 and number 6 is the same, did not change. This 3 and 4 is the same thing, it's vice versa kind of thing. And I think the most surprising thing is here, move operations are not independent. Okay, if you declare one of them, the other one is not declared for you. There are default move assignment and move constructors, but they are not independent. If you declare one of them, the other one is not declared for you. You need to do it yourself. Generation of special member functions. Okay, after C++ 11, these are the rules. Okay, the basic rule is, I mean, if you are into this stuff, if you are doing the move constructor or move assignment, then declare all of them, all 5. That's the general kind of rule of the thumb. That's not valid always. That's not the case always. I mean, sometimes you prefer to do only 1 or 2 of them, but most of the time, if you are going to touch one of the move operations, then you will implement, most of the time, you will implement all of those 5 operations. Okay, so Let me show you another source. Let me show you. I think I got this from a web page. Yeah, well, I don't think it is. It is from this guy. No semantics and R-value references in C++11. But it looks like my code. Some of the. Okay, I think this is truncated from the right side. But let's see some code from this guy. He says that he's writing this one. Yeah, okay. Array wrapper. He's writing an array class. Surprise, surprise. Everybody's writing array classes. Okay, inside my array, this is an integer array. I have an array pointer and the size, and I'm going to write the destructor. This one is the copy constructor, and let's look at this one. Integer array, destructor, copy constructor, move constructor, default constructor. I think I have all of them. Do I have all of them? Where is the assignment? He didn't do the assignment, but we can do the assignment later. But it looks like I don't like it because this is all. Why don't I do this? Make a search on the web. Let's look at the original website. Yeah, here it is. Is that? Yeah. Make it bigger a little bit. Okay, so this is the no parameter constructor. Okay, it says that I am producing this. Remember, p-vals is an integer pointer, and like with our PF array, okay. So I have a size of 64. Size is this. This is a conversion constructor from an integer, and this is a move constructor. See, let's look at the copy constructor first because we know this better. Okay. Our copy constructor takes the other object, and I declare some new size for me, okay, new size, and I allocate some new memory for me, and then copy the values from other place to my place, right? That's what I do, regular copy constructor, and this is the regular destructor, okay? So in this one will be called for objects that the compilers know that it's an, it's not going to be dead. Okay, so if whatever I am copying is not going to be dead soon, okay, it will call this one because the other one is a constant and I should not be modifying it, and it will continue living. But if the compiler knows that the other object that I am copying from is going to be dead soon, it's a temporary object, it calls this one, and this is what I do, right? Very efficient. I get the other object. See, it is not const. Okay, tell me why it is not const. Tell me why this is not const. I'm trying to hide the other part. Okay, implementation. Not you. Yeah, okay, you.
We assign pointer to null.
Yeah, because we are going to assign this one because we know that it's going to be dead, right? Because it's going to be dead. It cannot be a const, right? That's what we are going to do. We say that other, okay, p-vals will be null. Well, null PTR would have been a better solution. And other size is 0, but I copied it as pointer and size to myself first. Okay. Question. If I didn't write this line, I cannot. Well, if I didn't write this line, can I modify this thing? Can I write something on it? Is that what it is? Do I have such a thing in Explorer that allows me to put markings on the pages? I guess not. Anyways, if I didn't write this line, what happens? Where did it go? Yeah. If I didn't line 20, if I didn't write line 20, what happens? If I did not assign null to other objects, p-vals.
data will get distracted when the other object dies.
Yeah, because I know that the other object is going to die soon. It's a temporary object, right? Because it's going to die. When it dies, it will delete its p-vals like this. Okay. When it deletes it, well, I just made a shallow copy of it, right? I will be in trouble, right? I will be in trouble. So that's what we mean by always leave the other object in a destructible and valid state. The fact that the other object is going to die is not mean it's a junk object, okay? It's a valid object. It should be a valid object. The only thing is that I am only stealing its resources from it. Okay, good. So the copy constructor is something that we looked at already. Do I have anything interesting going on in here? With the regarding to the okay, this one copy constructor. No. Okay, let's go to our slides and we will continue on that one. Okay, so move operations for reverse compatibility. That means kind of the repetition of the rules. Move operations are generated only when no copy constructors are declared. Okay, no move operations are declared and no destructor is declared. If you declare any of them, then no move operations will be declared for you. Okay, good. Let's look at this example, very simple example. We will play with this one a lot. I have a simple class or struct. Doesn't matter, it's a struct, but it's a class, right? It has a static integer in it. Then it has a non-static integer. The constructor, no parameter constructor, assigns plus CNT to A. So every time I make a new object through this constructor, I increment the value of count by 1, and I assign the incremented value to A. Initially, this count is 0. Okay, so I make a first. I make 5, a vector of size 5. Okay, of these, and I use a pushback. Okay, and then later I ask each object, what are your numbers? Tell me your numbers. Okay, so I am expecting to have 1, 2, 3, 4, 5, 6. Okay, so far I didn't do much because I don't have any move constructors. I don't have any move constructors. I don't have any move assignment and etc. But what did the rule say? The rule says that if you okay, copy operations, if the two copy operations are in, okay, move operations are not in, if any of the copy operations is declared, then none of the move operations will be generated. Let's keep this rule in mind. In this case, I have two default copy operations, copy assignment and copy constructor declared, and move assignment and move constructors are declared too. Okay, so this is a simple program with such a simple class. Let's move on. Okay, let's talk about this move thing. Okay, should I erase that part? Yeah, I think I'm going to erase it. I think I am going to erase it. Okay, so modify that code a little bit. Now I am adding all big 5. Okay, copy constructor, copy assignment, move constructor, move, copy and move operations. But they don't do anything in it. They just say, I did this. Okay, I did this. And they just write these statements on the screen. That's it. So that we can understand what's going on. So let's see what's going on. When I say integer main, okay, this is swap. it will take two T objects, well, whatever, well, okay, it will take two objects, it's templated, and it will do the swapping, whatever, okay. So let's look at this main. Main says that make two objects for me, A and B. So this one will print S and S, right? Two S's. So when I call the swap, what happens? Since I am calling it by call by reference, no copy constructors will be called, right? No copy constructors will be called. And how about this one? This one will call, which one? Copy constructor, right? Not move constructor, but copy constructor. So this one will call here, this one will call, which one, this one, copy constructor, CTR. This one will call what? This one will call copy assignment. Why? Because A and B are objects, and they are going to still going to live, and compiler is going to call this copy assignment. So it is going to be copy assignment. How about this one? TMP is a temporary, right? TMP is a temporary, but how about this assignment? What assignment is this? Copy assignment. Who was talking it before? Okay, you stop. You don't say anything. Okay. TMP is a temporary object. I know that TMP is going to die in a few minutes. Okay, in a few moments. How about this assignment? Is that a copy assignment or move assignment? Well, I wish it was a move assignment, but the question is it a move assignment or copy assignment? It's a copy assignment. Why?
Because the compiler.
Say it louder. I'm not only.
Because in order to make it move, or I think we have to call few of them, not just one.
Say it again.
I understand that way. If there were few of them, for example, temp 1, temp 2, we were gonna create another temporary object which will resolve.
Well, yeah, I mean your choice is right. It is the copy assignment, but it is not. Your explanation is not correct. Why?
I think for the move operations to be called, the object needs to be created in the same line.
Yeah. Well, I mean, I called it temporary myself. The compiler doesn't know that it is any different than A and B, etc. Right? So, I mean, TMP will not be deleted at this line. It will be deleted here when the function ends. It will be deleted because the function ends. It's not deleted because in the same line. So this is copy assignment again. Copy assignment. So it will be as copy constructor, copy assignment, and copy assignment. Okay. Obviously, this is not what I want, right? Which ones do you want to be? Which ones do you want to be? Which ones do you like this to be a copy constructor or move constructor?
Copy.
Why?
A is not gonna die.
But internals of A will be wasted because I am going to assign.
It's we get it by the reference.
Yeah, but I am going to modify it, right? So whatever A holds, it will go away anyways. Well, I mean, maybe I was telling it in the wrong way. Well, A will be modified anyways, right? It's not going to die, but I know that it's going to be modified. So why don't I call the move constructor for this one so that I am using the A's resources, right? That's a good idea. So I like this to be a move constructor, and I like this to be a what? Move or copy. It is copy, I know, but I like that. I like it to be a move constructor, move assignment too. Why? I'm going to modify B2. So I like this to be a move constructor, move assignment, move assignment. Okay? I like it that way. So how am I going to do that? Well, the compiler doesn't think that A is a temporary thing. It's not going to die. Compiler doesn't think that B is not a temporary thing, and compiler doesn't think that TMP is not a temporary thing. Okay, so that's why I go back to the slide and read this again. In C++, we are not giving any guarantees of safe code. If you are not careful, you are going to shoot yourself in the foot. That's the rule of the game. Write your code carefully. I am going to give you all the powers, whatever you need. Okay, everything is possible. Just be careful. Okay, so we are going to write some careful code. That careful code requires this std move function. Std move function says that, well, if you like me, okay, this is what as copy, okay. If you like me, okay, to treat this A, B, and TMP as like objects that are going to die, then you can do this. Okay, make A look like a temporary object, or remember what we said before, an object of R value. A is kind of an R value. Okay, not an L value, but R value. It is temporary, it's going to die. That's what I am saying to the compiler. If I move A like that, okay, if I tell the compiler that treat A like is going to die, then this one will force the compiler to call move constructor. And this one will force the compiler to call move assignment and move assignment. Dangerous code, if you know what you are doing, if you know what you are doing, this should work. Okay, if you don't know what you are doing, then as always, I mean in C++, you will be in trouble. Okay, yeah.
Can we write our own std move, or is it integral to the language?
Well, it's a library function, right? It's a library function. Yeah, you can write your own.
Yeah, but,
well, I don't suggest it to write std moves.
Yeah, but for the class initializer list, I researched and we can't write it such that it will be portable to all operating systems. It can only be written to be compiler specific if we write our own initializer list class.
What are you talking about? Oh, yeah, move is kind of like that too? You mean, is that, yeah. Well, no, I am not suggesting to for you to write the move operation, move functions, okay? You shouldn't write it. And if you like to write your own, I don't know if it be, I don't know, I mean, I don't know the internals of how they are writing it, how they are making it compiler dependent. I don't know. Okay, so move basically tells the compiler that, okay, this is very similar to, you know, I didn't want to talk about this, but since this is the last picture, since these are only the last things that I'm going to tell you about the C++ language, maybe let's go to C++ constcast. There is a constcast operator in C++. You know what it does? Okay, so I have a constant integer reference RCI, right? RCI is a constant integer reference, right? I should not be able to assign anything to RCI, right? But this one does it. You are telling the compiler that I know RCI is a constant integer, I know, but I want to assign some value to it. Just make it happen for me. It works most of the time. Okay? Why am I telling you suddenly this? As I said before, C++ are powerful languages. They will let you do whatever you want. Taking away constants of something is something that you can do in your power. You should never do it, but it is possible. And this is something like that too. Okay, you are telling the compiler that Well, A or B are not going to die, but I like to treat them as like objects that are going to die or R values and move them so that I can do this. So if I do this, this one will produce S again, this one will produce S, this one will be, okay, move constructor, this one will be move assignment and move assignment. So what did I gain? If my objects are large objects, inside these move operations, maybe I can steal their resources. Well, in this case, I am not stealing any resources. These are as simple as some integers, right? I mean, because both the copy constructor and the move constructors are doing exactly the same thing. But as previously that I showed you, one of them is a large loop in the other example. The other one is a simple assignment operation. The difference could be as big as this, right? So with the swap, nicely written swap function, okay, with almost no cost. I mean, if you like to swap, the contents of two vectors, very large vectors, it will be very efficient, this one. Let's say you have two vectors, integer vectors, each of them holds 1 million integers in it. Swapping them will be as cheap as swapping two integers, right? If you write your swap like this. Good. By the way, remember, I think we talked about it a little bit. For the STL classes, there are swaps defined. Okay, swap these two elements inside the vector or between these two, etc. They all are all implemented using the move semantics. Okay, they are efficient again. Good. So std move. So it's going to be move constructor, move assignment, and move assignment. Good. Let's continue. Let's do some more. So right value reference cast. Okay. Right value. Well, you can write this kind of code. See this one. I have a vector v of size 100. v2 is another vector. I can push back this v by moving it to an r value. Okay. You are saying that I promise I will not use this v in anywhere else. Okay. So when I push back this one, this is the last time I am using this v. Do whatever you want with this v. Probably this pushback is smart enough to steal the internal data members of this v, internal resources, and push it back to this v2 in a very, very efficient way. Okay? Yeah.
Can I get arguments in a vector? In example, if I want a vector that 100 size with 5.
You mean instead of 100 is 5?
Yes, it's size, and I wanna all of elements is 5.
I don't understand what you mean. So tell me what you want to do. Just tell me the C++ code. A vector.
Int a.
Vector int a
100 size.
100.
But I wanna all of the elements is 5 initialized.
Oh, well, you are not talking about anything. You are not talking about the. You are not talking about the move semantics, right?
Yeah.
Yeah, it is possible with C++ 11 with the initialization stuff. I think you are saying that 7. So you want 5, right?
Yeah.
I think then you put 5. I think it's like that or before that. Just read about that. Do I have 5 minutes? What? C++ 11 initializer list. C++ 11 says that I am going to unify all the initialization techniques. There are 4 or 5 different initialization techniques. It says that I am going to do this. I am going to do this direct list initialization, this one. I think it is this one. Okay, this one, new works this way. New T something. I am sure there are examples here. Initialize it. We already know that. We know that. String. Regular constructor call. What is this? S122. I don't know what this is. These are strings, right? The one that you like to do with a vector of initialization. Yeah, I think, well, string is the same thing, right? Yeah. String is the same as vector, and you can initialize it this way or that way. I think the way I am doing is correct. Vector is something, and inside the curly braces, you put whatever you want.
I think it's after 100 comma and the value that.
Well, that comes from the C++ 98, like this. I am trying to use the C++ 11 way of initializing stuff. Definitely, I can do this 5, 6, 7, 8, something like that. Definitely, it works. But this one works, curly braces.
What will do? Again, based on 5, 6, 7, 8, 5, 6, 7, 8.
No, it is. Rest of them will be default values, I guess, zeros. This is the same rule as the array initialization. Remember, if you provide a smaller number of elements for an array, okay, then size, the rest of them will be initialized to zeros. It comes from C, right? Okay, so there must be a way of this. This is something we have from C++ 98. With C++ 11, you can use this curly braces to initialize. Curly braces to initialize. Initializer in list for vectors. I bet somebody auto initialized. Okay, C++. This is already we know. This is something that I told you, right? What else? Okay, this one works. This one works. Didn't give me this one the same number. I don't know, just you look this up. I couldn't find the answer. But your suggestion is solve this one better. So this is already in C++ 98. Okay, let's go back. This one, std move. Right value reference cast. I like my x to be a right value. Okay, usually has positive effect on performance. Many standard library functions utilize the right value references, and sometimes we have to use it. Might be dangerous, so we talked about it. That's part of the life. Okay, how about this one? What's going to happen? This one says, okay, make 5, 1, 2, 3, 4, 5 as objects, right? Make 5 of them for a vector and push back one more and print them out, their numbers. So it's going to be 1, 2, 3, 4, 5, 6, right? But we like to see what kind of copy construction is going on in this, or move construction is going on with this vector. Okay, so 5 objects will definitely be created. This one it will be created too. But when I do the pushback, is it going to? Do you think it's going to do the copy constructor or the move constructor? We expect the move constructor. That's what we wish, right? But if I do that, this is what happens. Weird.
Why do we expect more construction? I think it's gonna be a copy.
Because this is the no parameter constructor is going to work, right? Here. When you push back, the compiler knows that this temporary object is going to be dead, right? So it uses the second overload of pushback, which is the move pushback, not the copy pushback. Okay? So 1, 2, 3, 4, 5, 6, 5 and 6. A move constructor, what? Then after that, what happened? 1, 2, 3, 4, 1, 2, 3, 4, 5 copy constructors. And then, where are those copy constructors coming from? No, not you. You're talking too much. Weren't you sleeping yesterday? You were sleeping yesterday on Monday, right?
Yeah.
But still, to his credit, he was answering me right while in his sleep. Did you realize that? You were talking in your sleep and you were giving right answers? This class is full of interesting people. Okay, so where is these copy constructors coming from? Where are they coming from? Well, this is the last lecture of C++. As I said before, you know as much as I am. I know. Okay.
It's just a function from compilers calls it.
What?
It's not coming from anywhere. It's just a function. Compilers call it. Compilers call it.
Compiler calling it. Why do I have to copy 5 things? What's going on? I made 5 objects. Okay, they are all here, 5 of them. And I have a move constructor. Okay, 1, 2. Okay. 1, 2, 3, 4, 5. The 6th one is this one, right? Move constructor comes from the pushback. It steals the internals of this temporary. Then after that, while I am expecting 1, 2, 3, 4, 5, 6, there are 1, 2, 3, 4, 5 copy operations. What is that?
Because it's a move. 6 ones.
Because we pushed back SV to an S.
So,
That's why we copied S to SV, SV's elements.
but there's one copy, right? There is only one S. Think about PFRA. How did we write PFRA? Especially the modification that I did after to the PFRA. If PFRA doesn't have enough space in it, so what? It will reallocate more space, right? Then I am going to copy all that old ones to the new position, right? Did you get it? Okay. So I allocated only 5 spaces for this vector. When I push back the 6th one, it didn't have enough space, so it reallocated some space. Then it started copy the old position, the S objects in the old position to the new position. It uses the copy constructor to move them to the new position. Yeah.
Why are there 5 copy constructor calls then? Aren't there 6 objects?
Well, for the 6th one, it already does that using the move constructor in the right place. So it doesn't put it in the old place and copy it later. It's smart, right? So it allocates the space first. It puts the new object, this object, to the new space, and the rest of them will be copied from the old space. It had 5 S objects, right? 5. It allocated some space, more space. 6th one will be moved here. The rest of them will be copied. Okay? Okay, so you need to ask me a question now. You should wonder something. How come? Yeah.
Why it not use move?
Yeah, why it doesn't use the move constructor instead of the copy constructor, right? Copy construction is expensive. Move construction is something smart. Since I know that After copying all this data to the new place, these all will be dead, right? Why doesn't it use the move constructor, right? Yeah.
Will be deallocated.
Yeah, so I mean, just I can move them, then later I can deallocate them. I don't need to copy them all of them.
I think it is because we want to make it one after another.
Well, you can do the same thing with the move constructor too. Well, I mean, the answer is something complicated, something to do with the compiler. Remember what we said? We said that when you move something, you should leave your old object in a stable and destructible state. Compiler says that if you like me to do a move operation, okay, your old object should stay in the destructible and valid state. That's why it expects you to give some kind of a guarantee. That guarantee is this. Your move operation on S should not throw anything, okay? If you throw something while I am doing this movement, okay, then I will be in trouble because I don't know what to do with your objects. They will not be in a destructible state and etc. So give me this guarantee that your move operation will not throw anything, it will not cause any errors. If you give me this guarantee, okay, no accept, you will not throw anything from your move, then I can do this. Okay, so it is move, and move. Okay, so now it's efficient. You might say that who's going to know this? I mean, this is such detail, but again, everybody, when you write these kind of move constructors, put no except at the beginning. Like put the virtual keyword in front of every destructor. That's what we told you. Again, it's a very small detail, but it's an important detail. It's kind of like that too. When you write move constructors, put no except at the end of it. So tell the compiler that I promise I will not throw anything. I promise after the move constructor, I am going to leave the other object in a destructible and valid state, and nobody is going to object to anything. Okay? So that's the explanation, no exception. So it works. Okay? So by writing these kind of classes actually, your vector operations will work fine. Well, if you don't want to get involved about this kind of stuff, well, and if you don't have any pointers in your class, then don't write any of those. Don't write any of copy operations or the move operations, any of them. Then the default versions will work just fine. But if you need to write them, then you need to write all 5 of those. Okay, good. So what else? Before C++11, we had this move function. Its really meaning is move. Really, it moves from one place to another place. For example, this one. I have a list, I have a vector, and I like to move the elements between this beginning to the ending to the beginning of this vector. So from the list to the vector, I am going to move all that stuff. By move, I really mean move. It is not copy, it is move, okay? So I promise to the compiler that I will not use those elements again. So when you do this, so what am I gonna get? 1, 2, 3, 4, 5 constructors, okay? Then I have a vector of S, again, 5 constructors is going to come from there, and move operations, right? That's what we are going to have. So 1, 2, 3, 4, 5 constructors, and that one, and what else? I have these. What are the? Where are these copy constructors coming from? SV5. Oh no, it is making some space for these elements behind it. Then it is using the move assignment to assign those to the new elements. That's what it does with the list. But if I do the same thing with the set, okay, not with the list, but the set, with the set it doesn't work. It is all copy assignment. I guess it is internal workings of the set. It say that if I give you the internal resources of these objects, I will be in an unstable situation. That's why set doesn't give the ownership of those stuff. Doesn't work with the set. Maybe we should read about the documentation of the set. I don't know what it does. Okay, I guess that's it. So now I am done with C++, and I declare you experts of C++. Now you know everything that I know about C++. The rest is just reading more, okay? That doesn't mean that you know everything about C++. There are many other things that I didn't tell you, but I believe we talked about everything related to object-oriented programming philosophy in C++. Tomorrow I will start talking about Java, and most of the stuff again it will be about, not about Java, it will be about object-oriented programming, but without talking about the language specifics. You cannot talk about the language itself. So we will go into some details about Java too, but mostly it will be about, so this object-oriented programming principle is implemented like this in Java. Most of them will be very similar to C++. Java is designed by C++ experts, okay? They know C++ very good, okay? They are not ignorant of C++ details. That's why they say that, okay, this is bad in C++, we are going to change it, and we don't have to be compatible with C++. Okay, so that will give us a better understanding of C++, right? So why did they make this change? Because this was bad in C++, or it was inefficient, or it was not required, and etc. Okay, so again, it will be a discussion of C++, Java, and object-oriented programming language. Good. Any questions? Okay, see you tomorrow.